Today we're going to try and learn the Kadane's algorithm in under roughly 5 minutes. The problem is maximum subarray. This is one of the top interview 150 questions. Given an integer array nums, find the subarray with the largest sum and return its sum. And on paper, I know this seems like a relatively straightforward problem. We just need to find every possible combination of subarray that we can find the maximum of that, and returns the max subarray. That's O of n cubed. That takes O n cubed time to do the brute force way. I'm here to show you a way that you can solve it in O of n time using Kadane's algorithm. It's a form of a dynamic programming solution. It's DP in that we're remembering what we've done previously to use in calculation of our new subarray solution or maximum subarray. Let's take example 1 and let's walk through it using what is going to be this algorithm. So for starters, for those of you who don't understand how we do it the brute force way, I would basically say find the max subarray of all the individual elements, and then find it for every two elements, every combination of two elements, and then do it for every three, and then until we get up to the length of the array. And after we find every possible subarray and we find the sum of all of them, then we return what the max is, right? This algorithm, what we're saying is, all right, start with like a current max and an overall max, right? We have a cur max and an overall max. And what we're saying is that every iteration here, what is our current max? -2. What is our overall max? It's also -2. I'm gonna discard the overall max and we'll come back to it at the end. Now, when we take the next value, 1, we can either add it to our previous subarray value, or we could start off with it. If we start off with 1, our max would be 1. If we include it to the -2 and consider that subarray sum, our max would be -1. So we'd much rather want to go with the 1 because we're starting off at a higher point. Continue here. We can either start with -3 or do 1 -3. 1 -3 is -2. Just -3 would just be -3, and -2 is greater than -3, so we're going to go with that. Now let's see here. We can either start directly with 4 or aggregate -2 to 4, and I would rather directly start with 4. It's a much better starting point. Would I rather directly start with -1 or add it to 4? I would add it to 4. Would I rather directly start with 2 or add it to 3? Here I'd actually add it to 3 because we'd end up with 5 compared to starting off with 2. Here would I start with 1 or 1 plus 5? I would start with 6. Here would I start with -5 or would I start with 6 minus 5? 1. I would start with 6 minus 5, 1. And here would I start with 4 or 4 plus 1? I would start with 4 plus 1. After all of this, we always kept a track of our max or overall max, and that would return 6, which if you do the math should also be our max subarray sum for this subarray right here using Kadane's algorithm. Hopefully that made sense as to why we could do that, and we're only traversing the array once, which means we are solving it in O of n time. Let's go ahead and type up the solution, because now that we understand the intuition behind it, solving the problem actually should not take more than around like 6 lines of code. Let's do cur max t equal to 0, overall max t equal to 0, for num in nums, if cur max would equal the max of cur max plus num versus just the cur max, and then overall max would equal the max of overall max compared to the current max, and whatever is greater we store in that. At the end of all this, we simply return the overall max. And if we run this code, I'm running into an error. Why is that? Oh, that's because here it should be num. We're comparing the current max plus the num just compared to starting with the num. And if we submit this solution, if num is -1, it's the length of the num. So in this case, I think setting this overall max to -infinity ensures that compared to just the number is always going to be assigned, even if we just have one number and that number is negative. And effectively with that, we should be able to create a working solution using Kadane's algorithm. Hopefully this was a helpful tutorial that brushed over an important algorithm and showed its application. I'll be back next time. Thank you guys for watching, and please do like the video if you like the content. Peace.